Okay, so hello everyone. We have to continue our discussion on permutations. And this time, or in this specific topic, we have to consider distinguishable permutations. So what is distinguishable permutations? That means that if ever you have the same elements on a specific set. So for example, so if we have to look at this in a specific nga discussion, let's use this presentation here para mas maintindihan ta anong kinalain sini with your original na permutations. So if we have, for example, a collection of 10 balls, each a different color, then the number of permutations is, so you have, so may ara ka pulo ka balls, and then you have sari-sari tanan colors. But silingon, kung i-arrange sila naton, so but silingon, wala kita sang daw parehas-parehas kailan tawon because sari-sari sila color. That means, so that is equal to, so 10 factorial. So kay parehas sila or lainanay sila tanan colors. So how about kung in a specific na pulo ka bola, may ara kita sang parehas na color. Okay, so we have. Okay, so kay kun lainanay ang aton nga mga colors nga ginagamit on a specific, for example, nga balls nga category pa sini. So we have just one distinguishable permutation. All the ways of ordering these balls look exactly the same. So we have for this category, for example. So for example, wala may ara ka puro red nga bola. So, puro sila red nga bola. Okay, kung i-arrange ko ang aring 5 ka red, bisan baylo-bayluhon ko pa sila, ang pag-plastar, bali ang pag-recognize ko sila, do parehas lang sila Japon, bisan nag-change man ni sila posisyon. Because, so parehas sila color. That is same lang Japon nga distinguishable permutation. Pero nag-change ni sila positions. So in general, in considering a set of objects, some of which are of the same kind, then two permutations are distinguishable if one cannot be obtained from the other by interchanging the positions of the elements of the same kind. So, kinanglan naton i-consider na kung may ara parehas kind of object on a specific permutations kag gina-solve naton, kinanglan siya naton i-consider sa aton calculation. So, paano siya makaapekto sa aton nga specific nga problem or specific naton nga solution. So, we have here, for example, may ara kita pulo ka balls tanan, of which anom dari is red, ang other nga color ang other nga balls are of different colors. But silingon, okay, so for example, we have 1, 2, 3, 4, 5, 6. And then we have 1, 2, 3, and then we have 4. So, may ara kita pulo dari ka bola, and then dari is red, ang ibang nga colors is of different colors. So, pila ka distinguishable permutations are possible with this one. So, for the sa sining example, anong kinahanglan naton i-consider kung amo nga type of problem ang pwede naton ma-encounter. The key point here is that balls of the same nga color or any objects nga consider naton, hindi sila naton ma-distinguish or they are not distinguishable. Kay bisan saylo-saylohon tani, medyo mabudlayan kita mag-distinguish nga ginsaylo-saylo to sila gali or nag-change sila position. So each arrangement of the red nga mga balls sa sini nga example, so nga bisan i-rearrange ta na sila while we are keeping sang sini nga mga positions or sang sini nga mga values or sini nga position sa mga balls diri. So gives essentially those same lang Japon nga permutation. So bisan isaylo-saylohon tani without this or without moving this, those same lang Japon ang paglantaw naton sang arrangement. So, kung lang tawon ta or isolve naton ang aton nga, okay, so we have, sige. Kaya ang ari nga value, subot sining ang ari nga category, ang sa red lang tanan-tanan. So this is, kung i-arrange na ni ang red, we will have 6. So 1, 2, 3, 4, 5, 6. Bot silingon, kung i-arrange ta ang anom ka red, this is 6 ka arrangement. So kabalo kita nga 6 arrangement is equal to 6 factorial or 6 factorial. So there are 6 nga factorial rearrangement of the red balls nato for each fixed position of the other balls. So, thus, ang total nga number of distinguishable permutations is, ang himuon mo with this 6 nga factorial is, isipon mo tanan pila nga aton given, we have 10 balls. So, for the distinguishable permutations, kinahimo naton is 10 factorial divided by kung pila ang may parehas. So we have 1, 2, 3, 4, 5, 6. That is 6 factorial. This is now your permutation. So kung pila na di ang answer, this is your distinguishable permutation. Okay, so okay, this leads us into a general nga conclusion, wherein if, for example, a set of n objects consists of k different kinds of objects with, for example, may ara ka first object nga parehas, we have another object, we have another object. So, ang himuon mo, in order for you to identify the number of distinguishable permutation for this object is to solve for the factorial of the given nga objects divided by kung pila ka bilog ang nagparehas on a specific object. Kung may nagparehas naman nga another color or another letter, another color or another letter manda, i-divide mo lang sa imo nga total number of permutations. So, we have, okay, example. Okay, so example is, so find the number of different ways of placing 15 balls in a row, given that 4 red, 3 are yellow, 6 are black, and 2 are blue. So we want here to find the number of distinguishable permutation of these balls. So by formula, so hambal naton kinahanglan talang kaon kung pila tanan ang total permutation. So distinguishable permutation naton will be, so this is equal to, ang aton permutation is equal to total nga permutation, that is 15 factorial divided by, so apat ka red, subot siningon we have 4 factorial sa dalom. We have tatlo ka yellow. So we have 3 factorial. We have anong ka black. So but siningon we have 6 factorial. And we have dua ka blue. This is 2 factorial. Then divide. Whatever will be the answer will be the answer naton for this specific nga permutation problem. But silingon amo na aton nga distinguishable permutation. Okay, let us solve. This is, so 15 factorial divided by your 4 factorial times 3 factorial times 6 factorial times 2 factorial. So this is equal to 6,306,300. So we have 6,306,300. So this is our answer for this specific nga problem. Okay, so ang ini nga problem could also be applicable on worded problems or word-related problems. Example, so if you are asked to find a specific permutation, for example, of the word apple. Ang ini nga word, we have apple. But silingon, so if you are asked for this specific permutation, pwede natin makuha based on the word nga apple, ano nga itong himuon. So we have 1, 2, 3, 4, 5, but silingon may ara kita 5 nga posisyon nga pwede nga i-fill in. But silingon may ara kita 5. Okay. Aton permutation is equal to, so we have 5, 1, 2, 3, 4, 5, that is 5 factorial sa babaw, divided by, tanawon ta based on the letters, pila ka bilog ang nagsulit. May ara kita, letter P nga nagsulit. Kapila nagsulit ang letter P? We have 1, 2, but silingon, divide ta lang by 2 factorial. So, pila ni aton answer? So, we have 5 factorial divided by 2 factorial. That is equal to 60. So this is applicable on any possible on any possible problem, whether it be word ang ato nga ginasolve, whether it be cards, whether it be a balls ng mga problems, dice ng mga problems. So you can explore on different types of problem na pwede ma-solve using distinguishable permutations. Okay, so we have, okay, so one problem here, medyo laktawan ta lang, but we have to proceed with another type of problem. So 14 construction workers are to be assigned to 3 different tasks. So 7 workers are needed for mixing cement, 5 para sa laying brick, 2 for carrying bricks to the bricklayers. In how many different ways can the workers be assigned? So may ara ka 14 ka construction workers, i-assign to sila sa 3 different tasks. So may ara nga pwede naton ibutang for the mixing, 5 para sa laying brick, may ara kita 2 para sa brick to bricklayers. So or carrying bricks to bricklayers. So but silingon, on general ang aton nga permutation is ang kabilugan nga possible permutation naton is we have 14. So 14 tanan ka mga workers, but silingon nga kita 14 factorial. Pero pwede ta makasulit-sulit pili or pwede nga may ara ka 7 workers for mixing cement or cement mixing. Both silingon, we have 7 factorial. For laying brick, we have 5 factorial. For carrying bricks to bricklayer, that is 2 factorial. So, whatever is the answer here will be aton nga consideration. So, ang ginhimo ta diri on this specific na problem, we provided partition of the workers into 3 specific na group. So, containing may ara 7, may ara 5, may ara 2 ka workers respectively, giving us sa sini nga specific nga answer. So, 14 ang kabilugan divided by your 7 factorial, 5 factorial, and 2 factorial. So, which is equal to 72,072. Okay, so we have okay, so let us proceed with another type of problems na pwede natin gamitan sa concept of your fundamental counting principle. And this is ang ginatawag natin nga counting combinations. Okay, saan naton gamiton ang counting combinations kag saan gamiton ang permutations. This is ang aton nga target nga objective to learn sa subong nga discussion. So, when finding permutations, we are interested in the number of ways kung of ordering specific nga element sang specific nga group. So, may order kita nga gina-consider. In many counting problems, however, so orders are not important. So, for example, a poker nga hand be for example, regardless of kung paano mo sila i-arrange, same man na Japon ang magplastar sa ila. So, that is isa lang na Japon ka combination. So, take note lang, if we have to consider some counting principle or combination nga topic on the counting category. So, example, a poker player is interested in the number of possible hands, wants to know the number of ways of drawing 5 cards from 52 cards. So, makuha lang siya 5 cards out of 52 cards. So, without regard to the order in which the card of a given hand are dealt, we now, wala ka specific nga consideration kung diin dapat kung ano dapat ang una-una mong nga pilion, either it is ace, it is club, it is wala ka sang specific category nga ginabasihan. So but silingon ang ginanantaw naton diri is a specific combination. So we now develop a formula for counting situations such as this in which order doesn't matter. So wala naton gina-consider ang order of specific elements. So this is referring to sa ginatawag naton nga combinations. Naghamba ka combination, that is the may ara ka lang specific na number of elements sa isa ka specific na set. So, a combination of R elements of a set is any subset of R elements from that specific set. But silingon, for example, may ara ka 52 cards, makuha ka lang di 10 kabilog, makuha ka lang di 5 kabilog, that is already a subset ng sinanga group of cards without regards to the order. Wala taga regards sa order. If the set has n elements, then the number of combinations of R elements is denoted by this equation, C N R. This is combinations of n elements taken R at a time. Take note, paris-parehas lang sila with your combination kag permutation nga formula or ang aton representation. Magluwas lang sa permutation, ang aton pagplastar is letter P lang din. Okay, so for example, so we have here, consider a set with 4 elements. So, may ara kita set. We have elements A, B, C, and D. So, we have this. So, take note lang, nga kung ang aton nga isolve, for example, is combinations. So, ang pwedeng combination naton is A, B, C, A, B, D. So, we have B, C, D, kag A, C, D. So, amo ang possible combination. So, A, B, D. Okay? So, amo ni aton nga mga possible combinations. So, bisan maghamba ka pa B, A, C, still, amo lang ni Japon nga mga members or mga elements ang ari diri. So, or CAB, same lang na Japon. So, same lang ang mga elements, but silingon counted sila as isa lang ka combinations. Pero, kung maghambal kita ya permutations, matter ang arrangement of your elements. So, amo na ang kinalain of your combinations and permutations. Ang list of permutations naton is aring diri sa next naton nga slides. So, ang ABC, pwede sila naton i-arrange based on this. So, pwedeng amo niya ang arrangement sa aton nga mga elements of a specific nga combination. So, I do hope medyo naintindihan anong kinalain of your permutation and combination. Sa combination, wala naton gina-consider ang arrangement. But silingon, basta same sila element, isa lang sila ka combination. Okay, so we notice that the number of combinations is a lot fewer than the number of permutation. Okay, so based on the example naton, in fact, makita naton nga ang dere sa ating example, makita ta nga ang tanan-tanan nga combination, so kada combination ni are we have apat ka combination. Ang kada combination, we are generating tatlo ka permutation. So, buot silingon, ang ari nga combination, pwede ta sila kuhaon ang iya permutation. Ari, ang arrangement naton. And that is 1, 2, 3. This is 3 factorial. So that is 3 times 2 times 1. That's why we have 1, we have 2. Okay, so we have 3, we have 4, we have 5, we have 6. So 3 times 2 times 1, so that is your permutation or 3 factorial is equal to 6 ka possible permutation sa kada combination. So that means paano siya? So, paano siya i-plus star? So, kung mag-solve kita sang combination of three elements regardless, so, or sa imong nga three elements, kabalo kita nga miara kita 3 factorial permutation, take note lang since gasulit-sulit siya, para use man siya sa distinguishable permutation. So, daw, kumbaga, ang aton nga pag-solve is okay, so maghambak ka combination, gagamit kita dari concept of permutation still. So buot siningon, so let's start ko lang sang insakto. So we have 4 elements taken 3 at a time. So ang imong formula is naka-base sa formula of permutation. So permutation sang 4 and 3 4 ka elements or 4 ka elements taken 3 at a time divided by lang sa 3. So, ari, divide ta kay common yang mga factorial. So, this is 3 factorial. So, this is equal to, so, we have, amo na siya ang aton answer. This is 4 permutation of 4 times. So, we have this is 24. Ang permutation of 4 taken 3 at a time divided by your 3, which is equal to 4. Okay, 3 factorial is 6 kili, so we have 6. So 24 divided 6 is equal to 4. That's why ang muni nga may ara kita apat ka combination. So we have 4 factorial. So okay, so gamito naton ang concept para mag-solve kita sang different types of problem. But now let us differentiate paano gidla naton or sa diin naton gamiton ang permutation kag combination. Okay, so consider maghamba ka gani combinations aton nga general formula maghamba ka combination is so pares ang ginhimo naton kagina we solve for permutation divided by your r factorial. Okay, so magambal ta permutations. So that is solving for a specific nga permutations naton kabalo kitang formula ta for permutation is n factorial all over n minus r factorial. So ari siya. So since nag-divide ta by r factorial pagid, so dugang ta di r factorial sa aton nga denominator. So that's why combination formula nga general is this one. So just remember lang sa formula for your combination. So gamiton taman na siya for the problem kay para medyo mas hapos sa inyo maintindihan. Okay. Okay, so again, paano ta i-differentiate? Saan ta gamiton ang permutation, saan ta gamiton ang combination? Okay, so take note, hambal natin kagina if we have or if we are using permutation, we are using that if we are interested with the ordered arrangement of elements. So, permutation, kung ginalantaw naton ang ordered arrangement. Next, so if we are concerned with subsets without regard to order, then we are using combination. Subsets or groups or combinations, so that is your combination. Wala kaga consider sang order, that is combination. Okay, so we have here examples para ma-plaster naton ang aton nga combinations and permutations. So we have, so a club has 9 members. In how many ways can a committee of 3 be chosen from the members of this club? So in how many ways can the committee of 3 be chosen from the members of this club? So, diri sa sini nga problem, take note, wala siya nagplastar sa mga positions. That means order is not important here. So the committee is the same bisan sino man daang nga mga members ang ara sa specific na position. So we want the number of combinations sang 9 objects taken 3 at a time. So wala naton gina-consider kung sinong president, kung sinong vice president, and so on. But silingon, makuha lang dito tatlo. So, pila ang possible combination. So, we have combination of 9 taken 3 at a time. So, we have C of 9 members taken 3 at a time. This is equal to, so hambal natin kagina, formula or general formula is 9 factorial. So, ang kabilugan, 9 factorial divided by your R factorial. So, that is 3 factorial divided by your 9 minus 3 factorial. So take note lang, based on the general formula, that is your n factorial divided by your r factorial multiplied by n minus r factorial. So r is your permutation divided by r factorial. So we have so 9 factorial divided by 3 factorial over 9 minus 3 factorial. Or this is equal to your 9 factorial all over 3 factorial 6 factorial. So this is equal to, okay, kung isolve natin gamit ang mga calculators, this is equal to 84. Okay, so another problem. Okay, so parehas ang problem maging plaster natin kagina. From 20 raffle tickets and a hat, 4 tickets are to be chosen at random. So the holder of the tickets are to be awarded free trips to the Bahamas. In how many ways can the 4 winners be chosen? Okay, so based on this problem, we need to find the number of ways of choosing 4 winners, halin sa 20 entries. So the order in which the tickets can be chosen doesn't matter. Hindi pareho sa una natin nga problem kagina. Yung kinanglan natin i-identify sinong first place, sinong second place, sinong third place, and so on. But this time, makuha lang kita yung 4 ka winner. So the order in which the tickets are chosen does not matter. The same prize is awarded to each of the 4 winners. So we want the number of combinations of 20 objects taken for at a specific time. So we have combination of 20 taken for at a time. So this is, so we have 20 factorial all over your 4 factorial multiplied by 20 minus 4 factorial. So this is equal to, this is 4,845. So this is one of the specific na mga problem na pwede ninyo ma-encounter as we go through sang mga calculations on a probability ng mga topics. So we have, so the crucial step in solving counting problems is deciding syempre kung ano yung mo gamiton. Whether you have to use permutation, whether you use combination, or ang imo nga gamiton is just a fundamental counting principle. So, ang question is, saan o ka magamit sang sininga mga type of formulas? So, okay, so syempre ang pinadiri ka main point is whether ano kung ang question is saan mo sila gamiton, we are aware nga based on sa unang-una naton kaginang nga discussion, if for example may ara ka consecutive choices nga ginahimo. But silingon, ang imo nga next nga first nga choice makaapekto sa imo next nga mga choices. Then ang aton gamiton is your fundamental accounting principle. So may ara ka una nga stage and then you have another stage nga dependent on your first option. Then we have to use your fundamental accounting principle. Gina-multiply ta lang ang aton nga mga elements. Next is, question mo dayon is, kung hindi diri nakabase ang imo nga problem. So, for example, possible ways of, of sa mga letters, mga muna, or mga digits, combinations. Then, question naman dayon is, you have to choose between permutation and combination. So, paano mo i-distinguish? You have to ask kung does the order matter in a specific problem. We want to find the number of ways of picking specific number of object from a specific category. So, kinanglan natin tumangkuton, does the order in which we pick the objects matter? So, if the object of the order matters, kung kinanglan naton mag-specify sang order or kinanglan naton mag-specify sino dang president, vice president, sinong first, sinong second, dun buot silingon gamiton ta is permutation. Kung hindi kinanglanon kung hindi gamatter ang order, then ang gamiton mo is combination. So, amo na ang pinagid ka factor kung paano kita mag-decide whether we have to solve for using the basic principle of counting, permutations, or combinations. Okay, so we have a group. Example dere. So, of 25 campers contains 15 women and 10 men. In how many ways can a scouting party of 5 be chosen if it must contain 3 women and 2 men? So, take note, very common problem ni, especially sa board exam, ang mga amuni nga type of problem. So, halin sa 25 campers, may 15 women, may pulo ka men. Mapili kita sang 5 sa ila. Composed of 3 ka babae kag 2 ka lalaki. So, pila ang possible ways. So, based on this problem, we see that 3 women can be chosen. So, ang 3 ka women, pwede naton siya pilion. Halin sa aton nga 15 women. So, that means, wala sang specific nga arrangement. But silingon, we have to choose for women nga category. So, we can choose. So, may ara ka, since wala kita specific arrangement, that means we have your C15 3. Next, so, ang duwa naman ka men diri nga i-consider naton can be chosen halin sa pulo ka possible nga men nga option sa specific nga group. Since wala kita sang specific nga arrangement, therefore this is still a combination of 10 ka men taken 2 at a specific time. So, since mapili kita tatlo ka women, then after sina mapili naman kita liwat 2 ka men. But silingon may ara succession of task nga pwede nato ni perform. But silingon, this is ga-affect sa aton nga next nga problem. But silingon, we have to consider your fundamental principle of counting para makuha ang total nga value. So that means aton nga formula is, or ang aton nga answer is, we have C15.3 times your C10.2. So, nga ani ka mo ni sir ang formula. That means, so sa first ni mga stage, mapili ka sang imo women. Sa second ni mga stage, mapili ka sang men. So, magpili ka sang women, we have to use combination. Magpili ka sang men, we have to use another combinations. So, then, multiply ang result. This will be, aton answer dali nga makuha is, okay, wait. C15.3, C10.2. So this is equal to 20,475. Okay, so this is specific example kung paano na mag-combine ang tanan nga specific naton nga formulas. Okay, so I have here, I think, one last nga problem. So a committee of 7 is to be chosen from a class of 20 students. So the committee consists of a chairman, a vice chairman, a secretary, and 4 other members. And how many ways can this committee be chosen? So in how many ways can this committee be chosen? So take note, pwede ito siya i-divide into stages. Ang ato nga problem, but silingon sa first stage, mapili tada na isang chairman, vice chairman, kag secretary. So since may ara ka posisyon nga i-fill in, therefore dapat we are aware nga may ara ka order sa silingon permutation. Next, after mapili sa ila, mapili kita members. So members, wala ta nag-classify, wala ta naghambal nga dapat no may arrangement ang members. But silingon, ang gamito nato nga process is combination for the next nga stage. If nakuha mo na ni, so since affected sa imong nga process nga himuon sa first ang second, kinahanglan ta mag-multiply para sa aton nga total number of ways. So, okay, so question na subong is, ano ang atong permutations kag atong combinations? So that means halin sa 20 ka students makuha kita chairman, vice chairman, secretary. We have tatlo ka possible nga group. So we have 20 students taken 3 at a time. So we need to choose 3 officers and order is important. Therefore, permutation ang atong gamiton. So we have 20 or your permutation of 20 taken 3 at a time. So next, since we have to choose apat ka members. So nakapili na kita tatlo, pila na lang ang atong possible option. So since nagpili na tatlo, ang ato na lang option nga nabilin is 17 na lang ka student. Therefore, we need to choose some combination of 4 members halin sa 17 nga nabilin. So we have your combination of 17 taken 4 at a time. Multiply ito na lang dayon. So we have aton answer nga makuha is, so permutation is 20 taken 3 at a time. This is 6,840 multiplied by combination of 17 and 4 is 2,380. This is equal to 16,279,200. So this is ang aton nga example for the combination naman niya ng permutation and combination. So, amo ni ang mga possible problems nga pwede ninyo ma-encounter considering the fundamental principle of counting, permutations, and combinations. And this will be part of the problem nga pwede naton i-consider sa aton nga solving. Okay, so we still have one more problem nga i-plaster sa inyo for an example of permutations and combinations. So we're in, i-plaster natin siya in the next discussion video. Thank you. Stay safe. God bless.